Hello everyone. This video will provide information about the Killer Lake. Our group member are Mook, BB, and Pear. So let's get started with the first topic.
What happened at Lake Nyos? The date that happened is August 21, 1986. The location is Cameroon, West Africa. The event includes a cloud of carbon dioxide erupted from Lake Nyos. Over 1,700 people and 3,500 livestock deaths from asphyxiations. Victims were found where they feel no signs of struggle or violence. For the cause of disaster, first, carbon dioxide leak from magma chamber below lake. Second is water at lake bottom absorbed carbon dioxide over the times. The third is deep layers become supersaturated with gas under pressures. Next, triggers possible landslide, cool rainfall or seismic tremors, and then sudden pressure drop cause explosive degassings. For the colligative property involves vapor pressure lowerings, dissolved carbon dioxide decreases the escaping tendencies of molecules, allowing more gas to remain in solution under high pressures. Henry law C equal to Kp, where C is the concentrations of gas, K is Henry constant, and P is partial pressures. Higher pressure at lake depths allow more carbon dioxide to dissolve. And at the right side, you can see the demonstrations of colligative property in solutions. For the scientific explanations, the deep waters of Lake Nyos was under enough to pressure hold about 1.5 moles of CO2 per liters. When cooler lake waters or disturbance mixed with lake layers, the gas began escaping from the bottom waters is turned from its dissolved form into a huge cloud of CO2 gas. Because CO2 is heavier than air, it didn't rise. It flowed downhill like a deadly fox, pushing out the oxygen and suffocating people and animals in the village below.
Linked to colligative concept. Colligative property depend on quantity, not identity of fluid. High CO2 increases water pressure at date. CO2 equal to solute, water equal to solvent. Suddenly lead when external pressure change. At depth, pressure from water column negative 200 meter depth keeps CO2 dissolved. When the gas start to escape, more occurs the chain reaction, more gas came out, further lowering the pressure and so on. The gas cloud being heavier than air, pocket the ground and suffocate or often breathing life. Law and duration. Law explain how the vapor pressure of a solution change when the solute is added, specifically when the non-volatile solute is mixed with the solvent. The overall vapor pressure of the solution increases. The relationship is expressed as P solution equal to X solvent times with P pure solvent, where X solvent is the mole fraction of the solvent. Law and duration. If both component and volatile, the total vapor pressure of the solution equal the sum of their pressure. Ideal solutions such as benzene and toluene follow law exactly. Positive duration, figure HB forces higher vapor pressure endothermic. Negative duration, signature HB for gases, lowering vapor pressure, exothermic. Prevention and modern solution. Degassing pipe now installed in Lake now and Lake Monau. Second, control release of CO2 from bottom layers. Third, prevent future supersaturation. And last, continuous monitoring of pressure and gas concentration.
For the real-world relevance, other example of gas solubility and pressure, soda fuels, CO2 release when opened, scuba diving, nitrogen narcosis and decompression sickness, industrial gas storage, pressure tanks, importance of chemistry in environmental safety. For the human impact, in 1986, gas from Lake Niles killed over 1,700 people instantly. Many people had to leave their homes because they were afraid of more gas leaks. Some survivors had trouble breathing and suffered burns before the event. And for the environmental impact, thousands of animals died when the gas spread across the land, and gas made the lake water unsafe, killing fish and other water life. Crops and trees died because of the gas stopped them from getting air. The gas also made the water dirty and dangerous to drink. Conclusion: the disasters at Lake Niles shows that chemistry is not just something we learn in school. It can affect real life in serious way. Ideas like colligative properties and gas solubilities may seem hard, but they help explain how dangerous gas build up in the lake and cause many deaths. Nature always follows the rules of science, even if the results are surprising or tragic. By studying what happened, scientists have created ways to stop it from happening again, like using special pipes to release gas safely, and this shows that understanding chemistry can help us protect people and prevent future disaster. And this is our reference. Thank you.